Hello and good morning, everyone. Good evening to lots of you as well. Welcome to our global webinar series brought to you by Rockflow Dynamics. My name is Jessica Kalin from the RFD Calgary office, and today with me is Senior Advisor Joe Lynch to present to you modeling depositional sequences. We would like to thank each and every one of you for joining this webinar today. We have been overwhelmed with the response from these sessions and hope you enjoy them as much as we did. During today's webinar, all of the attendees' microphones have been automatically muted. However, we still encourage questions. If you navigate to your GoToWebinar control panel, you will find a questions window where you can submit your question to the presenter, who at the end of the session will answer as many as he can. The rest will be answered individually via email in the upcoming days. One last note is that this webinar is being recorded, so if you would like to view or share with your colleagues in the upcoming days, you can find it on our YouTube page under RFD Europe. Each webinar in our series has covered a breadth of topics from geomechanics to cloud computing to hydraulic fractures to well placement optimization. If you see one on here that you missed, again, you can find it on our YouTube page. Additionally, we're in the process of finalizing the topics for the rest of June and July, so stay tuned to our LinkedIn page for what topics will be coming soon. Each of our webinars touch upon a different aspect of tNavigator's integrated reservoir modeling platform, a single executable from building your static model to running simulations, from reservoir to surface. Now for today, we are live from Houston, Texas, and I would like to introduce you to Joe Lynch.
Thank you very much, Jessica. Let me just arrange to show my screen, which I hope you can see now. It says modeling depositional sequences.
Yep, you're good to go.
Good, thank you. So, good morning, good afternoon, good evening, depending on which time zone you're in. So here's a little bit of background on what's behind the title and the subject of this webinar. Not so long ago, a geologist asked us, what does tNavigator do to model depositional sequences? And my reply was that, yeah, we actively model depositional sequences all the time with tNavigator's Geology Designer, because tNavigator does well correlation and geological modeling, which items that help to implement the concepts related to depositional sequences. So in this webinar, I'd like to focus on those parts of tNavigator that help us model depositional sequences. Now, this means that it's not going to be a discussion on sedimentology, but it will include ideas on how sedimentological concepts can be incorporated into 3D models. I'll be using a variety of different data sets because the intention is to show the tools that are available, not the fine details of the models. So the parts of tNavigator that we're going to be looking in more detail at are around well correlations, the 3D grid and property modeling. We'll also be touching on horizons a little as well. But first, we'll just cover a little bit of background on the importance of understanding depositional sequences. I'll be going through some material. It's based on our training tutorials, very loosely based on our training tutorials. These can be found on our support site. Now, each tutorial takes approximately 30 to 90 minutes to complete, and I've got about 20 minutes or so left. So I'll be covering the material in a kind of very rapid way. So depositional sequences, just to set everybody in the right frame of mind. We find oil and gas in a wide variety of depositional sequences. both terrestrial and shallow marine, deep marine. We've got tools in tNavigator that help to model all of these environments. So why are depositional sequences important? The first one is at a fine scale of rock properties with porosity and permeability. A lot of the time, the depositional sequence is the primary control over those important properties. The next one is moving up to a larger scale, at the scale of internal reservoir architecture. The depositional processes are frequently a principal control on the fluid flow in the reservoir. So, for example, things like fluvial channels or stratigraphic compartments, these are controlled by the depositional environment. So how do we work on depositional sequences? How do we get the information we need? We use geological clues, and some of these clues can be in the model, in the data in the data set, and equally the information can be outside as well. It can be concepts or information from regional studies or even mud logs. So first we're going to take a look at well correlation and the tools that we've got in tNavigator to do that. So I'm going to bring in some data. Personally, I like to have a separate workflow in the workflow manager for bringing in data. So I'm just going to very quickly run that workflow. So I've brought my data in, and we'll take a look at what we've got. We've got some wells, 29 wells if I remember correctly, markers in the wells, logs in the wells, a 2D map that's going to help with the deposition environment, and some horizons. So now I'm just going to focus in on the reservoir area, and we will, okay, just adjust that size one more time to be able to filter some of these wells. And we're going to use this well filter tool. What I'm going to be doing is taking a transverse section across the middle of this area. I'll be using this tool here. It's very easy to draw the wells that I'm interested in. So now I've got a selection of wells that is called transverse, and I'm going to work just with those wells. Okay, so I've got my filter on. Okay, I'll go to the well section view, and I'll set things up in the well section view to look at to these logs and to do some interpretation. So I'm going to bring the 3 logs in, the gamma ray, the lithology, and the self-potential log. I'm going to move the self-potential and the gamma ray to the same track. I'm going to make sure that I can read both of the logs by disabling align markers by this. And now we can see the information that we've brought in, the 2 electric logs and the lithology interpretation. The lithology interpretation is a series of 1s and 0s. What I'm going to do now is to assign a template to make that something that's more geologically realistic. And I do that in the object itself. So once I've got the settings made in the object, I now need to go to the display and change the display to a color stick, and that will activate the template in the well section view that I've got. So now that's something that makes more geological sense. I'm now going to do some interpretation, but first the visualization change. It's possible to change all markers at the same time, which when you've got a lot of markers is very useful. So here I'm just going in and changing the color to something that's a little bit more readable. Now I want to go in and do some manipulation of one of these markers in one of the wells. I want to move the top 3 marker in well 2 down a little bit. So I select the mark that I want, interactively go in and move the marker down. So now I've got a new correlation and I can align wells by that marker. So that's the transverse set of wells looked after, but I've got other wells in the project as well. So I've set up a separate filter for those other wells. And now I'm going to use some new machine learning technology that we've got in tNavigator to help do the correlation, learning what it's got from the wells that we've interpreted and bringing that through to the other wells. So I'm going and setting things up for this well log predictor, just giving things various names, setting up the details and letting it run. So it's going to run, but I'm going to just look at another data set now for these results. So here I'm looking at these other wells, and I can see that the tops have been picked in these as well. So where this is useful is that the computer does the work and the geologist does the quality control. And as an example of some of the quality control that we can do, I'm going to generate a horizon based on one of these tops, and then I can go and grid that up. So to do that, I'm going to use the universal interpolation, which is the generally recommended method that we've got for constructing maps. I'm going to do it from a marker. Okay, and there's the marker selected. Set up some other parameters around the orientation of how I want that 2D grid to look. Okay, and use convergent gridding, which is typically my go-to method for gridding for many types of data. So there I can see that I've got a map, but I've got some quality control markers on the map as well, identifying an area over here where potentially I've got a problem with a mismatch and I need to investigate in more detail. So we've done some interpretation. Now we need to move to modeling. We need to propagate the information that we have from wells, seismic, and maps into 3 dimensions. And in the process, we need to honor both the data and the interpretation. But we also need to be aware of practical considerations. The modeling approach can be affected by a lot of things, not least the amount of resources available, in particular time. And it can be affected by the maturity of the asset, how many wells you've got, for example, and the decision that needs to be made. So the first step is to create a 3D grid, and the next step is to upscale blocked wells. And the upscaling process, the upscaling of blocked wells, the reason for doing it is because well logs are typically acquired on a 1/2 foot or 0.2 meter basis, and the grids are typically somewhere between 1 feet and 10 feet, or 1/2 meter to 3 meters. And we need to convert the log scale data to the grid scale data. all the time. It's always worth thinking before you accept the defaults, and it's always worth discussing the choices you make and their implications with others, in particular people that are going to be working downstream of you. So there are a variety of ways that surfaces can meet in reservoirs, and here is a selection of what we can model in tNavigator. This is a great example of where a picture is worth 1,000 words. So we can model basement, we can model erosion, off-lap, on-lap, etc. We can even in tNavigator model from surfaces that are not part of the grid. So here we've got a fluvial channel between top 2 and top 3, and we've used a surface that doesn't exist in the grid in order to be able to model that shape. So we're going to look at 3D grid design now. Here we've already got some data in there. We've got some porosity data that's come in from cores. We've got 4 horizons and 5 faults in the model. And we're going to go and build a grid. So we're going to firstly create something with a new name. Okay, grid demo. Click OK. Go over to the hammer button that brings the calculator up for us. Go to the grid that currently doesn't exist. There are a variety of ways that we can build grids in tNav depending on what's available, whether you've got faults in the model or not, whether your surfaces are there as point sets or horizons. So that's all possible in tNavigator. What we need to do now is we've deleted the information that was in the old model because we've made some changes. And now we're going to go through. We need to order the horizons from top to bottom in order to build the grid. So that shuffling process is what's going on now. And after we've done that shuffling, we can go and work and think about the horizon relationships and also the partition types, because they are the control factors on how these various surfaces relate to each other and therefore how the grid gets built. So this column here with layer count stroke height varies depending on whether you're using proportional gridding or another type of gridding. With proportional gridding, it's number of layers. Okay, we're moving on rapidly here. So I've selected my faults. I'm now going to go and make sure the grid is oriented in the right direction. Click apply, and I've generated my grid. Generates very quickly in tNavigator. So here I can see the 3D grid that's been generated. When I generated it, I generated a fault segments property. So each fault block is now its own separate segment, and I can model individually in different segments. The modeling that you see on the screen is because it's a visual effect of having both a horizon and a grid on at the same time. So I can go through and I can do some quality assurance on my grid. One way to do it is a visual check. So here we're using a filter tool to go and filter through to make sure the grid is matching up with the surfaces. But there are also other objects that have been generated as part of this gridding process. So faulted horizons and faults in the grids. These are a little different from the data that we started with, and they can be used for both quality control and for the basis of building different grids and different models. Sometimes grids can be very complex with lots of faulting. So now we're going to move on to the next stage, which is creating these blocked wells that I mentioned earlier on. So this is a straightforward process in tNavigator. Personally, I like to name all my blocked wells with a -BW at the end because that makes life a little bit easier when it comes to data analysis. I don't confuse the blocked well with the raw log. I'm going to upscale this porosity log. Okay, so we're going from the scale of the log into the scale of the grid. And there it is. There we have our blocked wells. So now that we've got our 3D grid and our initial blocked wells, we can get on to the property modeling, which is the result of all this. And we can do property modeling in a variety of different ways. There are deterministic methods. Some of them are listed here. We can do basic drawing with a brush, and that can be fun. We can do single faces by zone using the calculator. We can use the mapping algorithms like inverse distance squared or convergent gridding. We can also build properties from vertical proportion curves and 2D maps, and we can use kriging, which is a geostatistical method. So that's one group, and then we've got stochastic methods as well. The one that we're going to be focusing on is multi-point statistics in the next section, but there's also SIS, object modeling, and truncated Gaussian simulation. Now, sometimes even though you're in a stochastic modeling project, it can be worthwhile to go through with an initial pass on a deterministic model because it's quick and it's easy to do, and it can show you some potential busts that you might have with the data. So we'll go to property modeling, and here we're gonna take a look at, we've got a lithology log that's already had a template applied to it for reservoir or not reservoir. We've got a little polygon up there that we're going to use to create a training image for the multi-point statistic technique that we're going to be using. And the way that that is done is, in this case, is that we're going to bring in a trend map. Now, I don't like the template that trend map has been built on, so I'm going to pull in another trend map from the library and just change how that looks. And now it's obviously a binary parameter. So I've got the training image. I'm now going to generate the blocked wells on the 3D grid. Again, using this BW notation. So this is it's a lithology log, so it's a discrete log, and I'm going to upscale in a different way. Apply that. So there's my grid. It's hiding my blocked wells, so I'm just going to turn my grid off so that I can see my blocked wells, and I can see that those objects are there. Right, to get to multi-point statistics, I go to interpolation, multi-layer facies modeling. I give the property a name. I set in these various input parameters and click apply. Now, this takes a little while to run, but while it's running, there are two ways that I can create the training image. So you saw me bring one in from File, but there's also a brush tool over here, and you can use that brush in either the 2D window or the 3D window to generate these training images. And there can be multiple different faces in the training images. So now we're going to have a look at that parameter that we've generated, but firstly we need to show the grid. So that's the real live multi-point geostatistics. That's generated this model from the training data and the well data. Now, one thing in there is we've got some artifacts as just a byproduct of the process that have now been turned off. And the way to turn them off is to create another object called filter small connected components. And when we do that, it cleans the object up for us, and we've got control over how we do that. So tNavigator is a fully integrated solution. We've just looked at a small part of the functionality that we've got in the area of geology, but there's a lot more to it as well. And typically, these models are going to go through to reservoir engineering, reservoir simulation. So most of the time, the workflow is this forward workflow, but also in tNavigator, it's possible to do a reverse workflow and to use the production data that we may have in order to condition our geological models. And that's something that can be done as part of the history matching process. So to summarize, it's important to know your depositional environment because it can control fluid flow, and getting it wrong may have some very expensive consequences for oil companies. The next point is that the process needs to be iterative and balanced. Also, we've got some machine learning in there now that can help accelerate the interpretation process. We've got a variety of different tools in tNavigator to help you model your depositional sequences, and we've touched on those as we've been through the presentation. And then the final point is that it is practical in tNavigator to use production data to work with your geological interpretations. So
Wonderful.
with that, I'm going to hand over to Jessica.
Wonderful. Thanks, Joe, for your presentation. And thank you, everyone, for your time and attention today. For your reference, this webinar was recorded, and you will be able to find it on our RFD Europe YouTube channel within the next day or two. Now we're going to take the final few minutes just to answer any questions from the audience. Any remaining questions that we don't have time for at the end, we will answer after the session, and we'll send you an email with the answers to those questions. So if you still have a question, feel free to type it into that questions box. And in the meantime, I'm going to hand it over back to Joe to get started with the first couple of questions that have come in. Joe?
Thanks, Jessica. Okay, here's one. In fact, it looks as though it comes from someone that's already using tNavigator. So the question is that he's aware that the tNavigator simulator uses GPU processing, GPU being graphics processing unit. Does Geology Designer use processing on the GPU as well? And the answer to that is yes, it does. It's something that first came in about a year ago. So we use the GPU for some of the geostatistical routines, and we've seen that that can speed up those processes between 4 and 6 times. So, so yes, it does, and yes, it makes a difference. Another one on how do I choose between object modeling and multi-point statistics? Woo, okay, that's something that could take a long time to answer, but a lot of the time it depends on your data. Object modeling is very good and gives great results when you don't have too many wells. But once you have a lot of wells and a lot of conditioning parameters, object modeling can find it quite tough. And that's where multiple point statistics comes in. And we're seeing increased use of multi-point statistics now for these kind of more complex problems. So I think we're out of time now, Jessica. So do you want to wind up?
Yeah, thanks, Joe. Sorry, everyone, we kept you 2 minutes past what we told you we would. Thank you all again. Stay safe and stay healthy. And next week, we will be taking a 1-week break from the webinars, but we'll be coming in with some more amazing sessions the week after that. So please stay tuned to our LinkedIn as well as your emails for what the topics coming up will be. Also, in the meantime, if you have a suggestion on what topic you would like to see, please send us an email at asktnav@rfdyn.com. Thank you very much, everyone, and take care.
Bye, everyone. Thanks for your time.